Hello everyone, I am Brandon Ordoñez from ECE41 and today I will be performing our experiment number 4 for our Internet of Things laboratory, which is entitled Exploring the Smart Home. Hi, so now let us begin with our experiment. So the objectives of this experiment are explore the smart home and analyze the usage of fog computing in the smart home. So for the background of this experiment, in this activity, you will explore the smart home example. Depending on the application, some data is best processed close to the source. The smart home example takes advantage of fog computing to monitor and act upon the levels of smoke detected in home. So for the first part, it is exploring the smart home. So step 1, understanding the devices that compromise the smart home. Commonly, ISPs deliver data and video over a single coaxial cable. Starting from the attic, a coaxial splitter is used to separate the video signal from the data signal. Two coaxial cables leave the coaxial splitter in the topology shown. Which devices does the coaxial cable connect to? So here, this is the coaxial splitter. So the two devices where uh, the coaxial cables are connected are the modem, cable modem, and the TV. There. So next, the cable modem is the interface between the ISP's network and the home's network. To which devices does the cable modem connect to? So the cable modem is connected to the home gateway, which is then connected to the solar panel. Next, the home gateway acts a concentrator and router to all internal home devices. It also provides a web-based interface that allows users to monitor and control various smart home devices. Notice that the home device can connect to the home gateway through either a wireless and/or wired connection. Packet tracer uses dashed beams to represent wireless connections, but it can make it hard to read when too many devices are present. To turn it on, go to Options, Preference, Hide tab, and uncheck Hide wireless cellular connection. So let's go to Options, Preferences, Hide, and Hide wireless cellular connection. There. So upon doing that, the wireless connections have been shown in our packet tracer. Next, list all home devices connected to the home gateway. So first, um, the lamp, smart window, um, smartphone, tablet, smart water meter, smart alarm, smart sprinkler, temperature meter, smart coffee maker, smart door, and the garage door. These are all connected to our home gateway. Next, interacting with the smart home. The devices in the smart home can be monitored and controlled remotely through any computer in the home. Because all smart devices connect to the home gateway, which hosts a web-based interface, tablets, smartphones, laptops, or desktop computers can be used to interact with the smart device. So, okay. First, let us hide um, the wireless connections so we can see the connections better. There. So, first, click the tablet, desktop, web browser. In the address bar, we will type the IP address 192.168.25.1. So here, a home gateway login page has opened. And next, we will type admin for the password admin. There. Afterwards, what is displayed? So the displayed page shows the IoT devices that are connected to our home gateway. Next, the smart door is currently unlocked, represented by a green light on its doorknob. So, smart door. It is unlocked, and we can see that since there is a green light in the doorknob, but it can be locked remotely. Click the smart door in the browser to expand the options. Click lock. Was the door locked? Yes, the door is locked since from being green, the light turned red, which means that the door is locked. Since there. Click unlock to unlock the door. So the door is now unlocked since it shows a green light. Next, click the smoke detector in the browser to expand the section. Smoke detector. There. Can the smoke detector be controlled? No. Click the smoke detector in the browser to expand the section. What is the smoke level reading provided by the smoke detector? So the smoke level is 0. And we cannot control the smoke detector since its main purpose is detecting um, the presence of smoke caused by fire. Smart devices can also be controlled directly, representing physical interaction. Within the logical work area of Packet Tracer, hold down the Alt key and click the Smart Coffee Maker to turn it on or off. So I will press the Alt key and I will press the Smart Coffee Maker. There. I can turn it on and off simultaneously while pressing uh, the Alt key. Next. Fog computing in the smart home. The MCU added to the smart home is used to monitor the smoke levels read by the smoke sensor and decide if the house should be ventilated. If the carbon monoxide level raises above 10.3 units, the MCU is programmed to automatically open the window, front door, garage door, and start the fan in high speed. This action is only reverted, close doors and windows and stop the fan when the carbon monoxide level drops below 1 unit. So first, run the classic car. The owner keeps a classic car in the garage and needs to be run occasionally. The classic car generates carbon monoxide which raises the levels within the premises. Okay, so click tablet. Navigate the desktop to web browser. So we are already here in the IP address of the home gateway. Click on the smoke detector within the smart home. Leave this window visible. Okay, next. Start the engine. I click on the smoke. Okay. Start the car engine by holding the Alt key and clicking the classic car. Alt key, classic car. There. What happens to the air inside the house with the car running inside? So as we can see, smoke appeared from the back of uh, the classic car. And again, let's try. So we could see that the windows, the smart fan, and the doors opened after pressing classic car. Does the MCU close the door and windows and stop the fan? Let's try. So upon clicking again the car, it stopped producing carbon monoxide, which led to the smart window, the fan, and the smart door closing. But if left if left unattended, let's try again. There, if left unattended, um, the windows would not close, the smart door would not close, and the smart fan would not stop. The garage door too, since uh, since the reading from the smoke detector is 1.64, and it will only stop um, when the carbon monoxide level is below 1. So we should click this again and it will stop. So the air quality inside the house, after stopping the classic car, the smart window, smart fan, smart door, and garage door all closed. So now that we are finished with the experiment, it's time for the reflection. This example shows that the decision between cloud and fog processing depends on the application. In the smart home example, fog computing was the best option. In the smart home example, the data generated by the smoke sensors were processed and used to make decisions regarding the house air quality. In this scenario, there was no need to send out sensor data to the cloud for processing. Cloud processing would slow down the response time, potentially putting lives in danger. Another possible problem relates to the internet leak. If the connection to the internet was lost, the entire system would fail, putting lives at risk. So again, let us observe what would happen. So let's enter again the IP address 192.168. So here, smoke detector, and let's try to start the classic car. So as we can see that upon seconds after the classic car has started, the garage door opened. This means that the level of carbon monoxide became higher, so or the smoke. So it is above 1, which leads to the smart window, smart fan, smart door, and garage door opening. So that is it for our experiment number 4 in Internet of Things Laboratory. Bye!